Hello there. So, in this video, we're going to explore how much oil is consumed by humans, and then determine how does that compare to the atmosphere. Like how much, in fact, what we really care about is how much carbon is being burned, and how much carbon that compares to how much carbon there already is in the atmosphere. So, really, the question that's often asked is like, well, the Earth is so big. How can we as humans impact it? And we're going to go through some numbers and we'll actually see what the numbers turn out to be. Okay, so in order to really do that, we want to compare. It's really, we can write down what do we ultimately care about. We care, one, how much carbon humans produce. Okay, okay, and then two, we are going to care about like basically what's in the atmosphere already. What is in the atmosphere already. Okay, so that's ultimately what we're going to do. In order to do number one, though, it's this is actually, there's lots of things that go into it. There's going to be like how much we burn from just driving around. So there's going to be like kind of energy related. So driving around, all the coal we burn, uh, all the natural gas we burn to heat our homes, etc. Um, um, flying around. Then there's stuff around like food production, like uh, uh, there's uh, there's many other factors, but let's just focus only on just the oil that we burn, just to get an idea. And then we can get an order of magnitude is like, are we burning so much that that's actually relevant? That's comparable to what's in the atmosphere that we could actually impact it. So let's start by exploring how much carbon we produce and consume. So we're going to start by looking in Wikipedia, and if you see here, this is a page on peak oil. You can just Google for like um, for oil consumption, and you'll see what they're. This is like something that someone's projecting is how much we're going to consume in 2030, and right now they're saying we consume 86 million barrels. Okay, so let's write that down. So we already know that we're for oil. So for number one, just for oil only, we use 86 million barrels of oil per day. So actually, let's convert that into something we might all be familiar with, which is gallons. So you can go look up what the conversion is between gallons and barrels. So barrels, you might have seen them like on the sides of roads and stuff. They're pretty big, but they can hold 42 gallons. Actually, doesn't that seem kind of small? Let me actually double check that. Yeah, actually, so I just double checked the number, and I'll just show you. I went to like some conversion table. You can see here it's 31 gallons per barrel. Okay. Here they convert gallon into barrel, but you can do the inverse of that. Okay, so um, we're going to have then, to convert it to gallons, we're going to put gallons up here, and it's 31 per 1 barrel. Okay, we can cross out the barrels. Okay, so that equals, and I'm going to put all this in scientific notation. Okay, so we have a million is 10 to the 6. This is 3.1 times 10 to the 1. And then we're going to have to multiply the 86 by or we could multiply the 86 by the 31. Okay, so what is that? So it's 86 times 31 is 2,666. So that's going to be, let's say, 2.7 times 10 to the 3 for multiplying 31 times 86. and then we still have the million from before, so that's 10 to the 6. So that equals 2.7 times 10 to the 9 gallons of oil consumed per day. Okay? And then now let's go figure out how much carbon is in that. So it is true that not all of that oil that's consumed is gasoline. Some of it is heating oil, some of it's used to go into asphalt. There are a lot of components in oil, but a lot of it does get released. If we just leave it all as oil, maybe we can multiply by a factor of a half. There is one table I found somewhere which said that roughly half, or if not more, can be converted into gasoline and jet fuel and things like that. But let's just assume that it's all. So turns out that if you look at what gasoline is made up, it's mostly octane. You always hear the word like high octane. So that's C8H18. So that's like what a gasoline is. It's like a chain of carbons. Actually looks like all these carbons connected, and there are 8 of them, and then they're all just surrounded by hydrogens. Okay, so it doesn't really matter what the actual layout is, but it's just to tell you that mostly it's carbon. And in fact, by weight, if you work out the math, you can do this by actually knowing that the typical weight of carbon is 12. The atomic weight of carbon is 12, and the atomic weight of hydrogen is 1. And so the ratio of carbon to the whole thing, so it's carbon to octane, is equal to 8 times 12, because there's 8 carbons, and then you add 8 times 12 plus the 18 hydrogens times 1. So that equals 84%. So 84% of the weight of octane is in carbon. And the reason I'm doing this is that we can then convert these gallons into determining what's the weight of the gasoline or the oil that actually is carbon. Okay, so how do we do that? So the typical density of oil, or how much does the oil weigh? Well, it actually, if you look it up, it's about 3 kilograms per gallon. Now that, just by the way, that's not unreasonable, right? If you look at like water, you weigh a thing of water, it's pretty heavy. Like 3 kilograms is a significant amount. So if you look it up, you'll find that. So that's how you can convert this quantity here, the total amount of volume of oil consumed, into a weight. So if we do that, we have to take the 2.7 times 10 to the 9. We have to multiply that times 3 kilograms per gallon. I should have also written over here, this is actually gallon per day, and then we have kilograms per gallon. So this gives us roughly 3 times 2.6 that's 6, that's 21, so it's about 8. Let's just make it 8. 8 kilograms, sorry, 8 times, 8 times 9 times 10 to the 9 kilograms of gasoline, or kilograms of oil consumed per day. Okay, actually, I think I'm getting close to running out of time, so I'm going to have to stop there. But this is then, you'll see this, we'll continue in the next video, but we are consuming this much weight of oil per day, and we're then going to use the conversion of how much of it's carbon to determine how much of it is being released per day. So I'll see you in a minute.